Hi my dear friends and students, welcome to the Creations. In this video we are going to discuss introduction of digital electronics. Let's discuss the definition of digital electronics. Digital electronics is the sub-branch of electronics that deals with the digital signal for processing and controlling various systems and subsystems. So this digital electronics only involves digital signal. For any kind of operation, signal used here are in the form of digital. Next, why we need digital? Most of the natural signals around us are in analog. So what is the necessity of digital? Why we go for digital? First one, it is noise immune. See, analogs are highly affected by noise, whereas in digital it is less affected by noise. Okay, so that is the first thing. Second, designing and operations of digital circuit is simpler than analog circuit. Third, high accuracy and precision. We already seen digital signals are noise immune. Since it is a noise immune signal, signals won't affected by noise. So it will produce the output with high accuracy and precision. Fourth one, information storage is simpler. In analog, infinite number of data are there. Because analogs are continuous in nature, we need to store large number of data. Here in digital, limited amount of data are enough to store. So it is very compact and information storage is simpler. Then it is programmable, it is easy to program digital signal. Next, disadvantages, it is expensive because it involves switching elements, so it is expensive. Second, analog nature of real world entities. We already seen most of the natural signals are analog. So if we want digital signal, we need to convert analog into digital. So that is quite difficult. Next, energy consumption. Due to the production of heat, here energy consumption is high when compared to analog. Next, coming to applications, nowadays everywhere we are using this digital electronics. For example, computers, calculators, smartphones, automatic glass doors, traffic light, radar navigation and guidance, washing machine, printers, digital cameras, microwave oven, and also in military. So like that, in so many areas and fields we are using this digital electronics. Next, very important thing we need to discuss, what is digital signal? How to produce digital signal? What is the difference between analog and digital? Because so many people are having confusions with the signal, analog, digital, continuous time and discrete time. Whether the analog signals and continuous time signals are same, whether the digital signal and discrete time signals are same. Let's see about that. You all know that signal is a physical quantity that varies with one independent variable or more than one independent variable. And also it carries some information. For example, my voice is a signal because it carries some information. Okay. Now see this one. These two are signal because it is a physical quantity which varies with time. Okay. This is the time axis and this is the amplitude. So here also this is the time axis, this is the amplitude axis. Now see the first one. Here I can define the signal for every instant of time. Here for 0 I can define the signal. Even for 0.000009 I can define the signal. Like that 3.33333 I can define the signal. So here for every instant of time I know the value. I can define the signal. So this is the continuous time signal because here the time is continuous. Okay. Next, see this one. Here I can define the signal only at 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 like that. Okay, here I can't define the signal at 1.5 or I can't define the signal at 3.3. So here I can define the signal only at discrete instant of time. So it is a discrete time signal. So for both continuous time and discrete time, you need not to consider amplitude. That means y-axis. Only thing you have to consider here, time axis. If time axis is continuous, then that is a continuous time. If time axis is discrete, then that is a discrete time. So for continuous and discrete time, you have to consider only time axis. For analog and digital, you have to consider amplitude. Okay, you have to consider this amplitude. Mean here the y-axis value. You need not to consider time axis. You need not to consider time axis for analog and digital signal. So here, if the amplitude is continuous, then that is a analog signal. If this amplitude is discrete, then that is a digital signal. See, this signal is continuous time and also analog, because in time axis also continuous and in amplitude also continuous. Now see, infinite number of amplitudes are here. 0, 0.1, 0.003, 0.004, 1.2, 1.3, 1.7. So like that, infinite number of values are here in amplitude axis. So it is continuous time and also analog signal. But see this one, this is the digital form for this analog signal. So how to convert analog into digital means by means of quantization. Quantization is nothing but a rounding of the values or truncation. Rounding of the values means you can say 1.0005 as a 1. Like the 2.1222 as a 2. So this is called rounding off. So by means of quantization, I can convert analog signals into digital. In digital, the amplitude is discrete. See this one, here I am considering only 4 values. 0, 1, minus 1 and minus 2. Okay, here you are having infinite number of amplitude. But here I am considering only 4 values. Okay, you know that digital can be represented by means of zeros and ones. So I am representing 0, 0 as minus 2, 0, 1 as minus 1, 1, 0 as 0, 1, 1 as 1. Here blue color represents analog signal and red color represents the digital signal. So how I am taking quantization? In analog, you can say at time 1, the amplitude is 0.009. So here in digital, it contains only 4 values. So you cannot plot the amplitude 0.9. So I am considering the amplitude ranging from 0 to 1, that as a 0. And the amplitude greater than 1, or I am considering that as a 1. And again, the signal from 1 to 0, that as a 0. And signal ranging from minus 1 to minus 2, I am considering that as a minus 1. Nearest value for this signal is minus 1. So I am considering minus 1. So like that, you have to quantize the analog signal. So by means of quantization, you will get the digital signal. So here, to convert analog into digital, you need to take quantization. So by means of quantization, you can convert analog into digital. So to convert continuous time into discrete, you need to take sampling. By means of sampling, you can convert continuous time into discrete time. By means of quantization, you can convert analog into digital signal. Okay? For better understanding, see these 4 signals. First one, it is continuous in time axis and also in amplitude. So it is continuous time and analog signal. Second, and see this one, here it is discrete in time axis and continuous in amplitude axis. It seems like a discrete in amplitude axis, but actually it is continuous in amplitude axis because we are not taking any quantization. Okay, so this is discrete time analog signal. Now see this one. In amplitude, you are having only 2 ranges. This one and this one. If I am considering this as a 1 and this as a minus 1. 1, minus 1. So like that you are having only 2 values. So this is a discrete in amplitude. In time axis, it is continuous. So it is continuous time digital signal. amplitude axis. So it is a discrete time and digital signal. Okay. Now see the analog. Here the signal are not quantized. Okay. It is having infinite number of amplitude. Whereas here you are having two ranges. This one and this one. Okay. So here the signal are quantized. Here the signal are not quantized. So that is the difference between analog and digital. I hope you understand these signals. Next class we will discuss another topic. Thanks for watching this video. If you like this video, subscribe my channel, click the like button and share this to your friends.